All right, students, let me try a video solution here from chapter 12. It's number 23. It says a cubic meter of copper has a mass of 8,930 kilograms. Okay, so here's going to be this cubic meter of copper. I guess maybe it's kind of three-dimensional, so maybe I'll try to make it look three-dimensional. But it's 1 meter by 1 meter by 1 meter. So there's my big chunk of copper. And maybe to make it a little easier, I'll make it a little smaller and kind of do a square down here. This will be my free body diagram here. Because it says here, the block of copper is lowered into a lake with a strong cable until the block is completely submerged. Draw the free body diagram on the block. Okay, so this is kind of taking us back quite a few chapters and our forces, but my general statement to you was to do the force of gravity, so I'll put an mg, and everything touching it. So there's this cable holding it, and so I'll call that T. And of course, what's new for this chapter is that there would be water molecules around it and touching it. And our physics argument was that these water molecules would be pushing in on both sides. They would also be pushing down from the top, but they would also be pushing up from the bottom, and they would push up from the bottom more than the top. And so the net effect would be an upward buoyant force. So the free body diagram would look something like this, where you would have one thing pushing down, that's mg, and you would have the tension in the cable as well as the buoyant force pushing up. So there's the first step, draw the free body diagram. Then it goes on to say, find the buoyant force on the block and the tension in the cable. Well, I'll start with the easier one. The buoyant force is equal to the weight of the displaced fluid. So weight is mg. Although I want to be careful here, this is the weight of the displaced fluid. So let me put a little FL for the mass of the fluid displaced by this cube of copper, because I don't want you to confuse it with this M, and I'll put a little C for copper. Maybe I should put Cu for copper. Okay, so those are not the same numbers. Now, figuring out how much mass is displaced, let me use density equals mass over volume. Because again, being careful here, we want to apply this density and mass to the fluid in order to figure out this buoyant force, not to the object itself. So the density, which is of course water, would be 1,000 kilograms per cubic meter. The mass, and I'll put FL for the fluid, and the volume displaced, well, that's just the volume of this cube, so that's 1 cubic meter. So, in short, the mass being displaced is 1,000 kilograms, because that is the, density of water, 1,000 kilograms per cubic meter. By the way, 1,000 kilograms is also the same as 1 gram per cubic centimeter. So you could use there and then convert up to those units. But this one's probably worth remembering also. Okay. All right. So with that in mind, I can then answer the question, what is the weight of the displaced fluid, or in other words, what is that buoyant force? It would be m of the fluid times g. The fluid, we just said, would be displacing 1,000 kilograms, and g would be 9.8 meters per second squared, or you could even do a tan, And then, of course, that makes 98,000 newtons. Oops, 9.8, sorry. 9,800 newtons, or if you wanted, call it 10,000 newtons. All right, so there's the second part of it. So we've drawn the free body diagram. Now we've got the buoyant force. And then finally we can get to the harder one here, the tension in the cable. Although I say harder, but it's really old material because this is the new material, the buoyant force. But coming back to our free body diagram here, we know if we're just going to be holding this, that the sum of all the forces, which equals to ma, and we're just holding it there, would have to be 0. So the acceleration would have to be 0. And so looking at this diagram, we would have tension pulling up, we would have buoyant force pulling up, we would have the weight of the copper, so I'll go mg, but put a little cu under here for copper, and that has to come out to be 0. Okay, or to get what we're really after now, the buoyant force then, I'm sorry, the tension would be, and I'll move the mg to the other side of the equation and subtract off the buoyant force. So let's see. They told me that the copper has a mass of 8,930 kilograms. So when you multiply it by 9.8, or 10, and subtract then, what do we get here? We got 9,800 newtons, we will get the tension. Okay, so 8,930 times 9.8. So that is the weight of it. It looks like 87,514. And the tension in the cable doesn't have to be quite that high because 9,800 is being supported by the buoyant force. So the cable only has to support 77,714 newtons. Good. Hope that helped.